Good afternoon, pilot teachers, and good afternoon, students. Okay, thank you. Sit down. Okay. Our lesson today will see us look at more on contour patterns and then identifying contour patterns with landforms or features in reality. From our last lesson, we looked at how we can identify contour patterns with slopes. And we did say that the closer together the contour patterns, or the closer together the contour lines, an area will have a steep slope. The further apart from each other the contour lines, the gentler the slope. If we have a contour pattern of the same distance apart or away from each other, then we say that that area has a uniform slope. If we find that the contour patterns at the top of the feature are close together, and at the bottom of the feature they are wider apart, then we say that slope is a concave slope. And finally, if we have a contour pattern that sees the lines closer together at the bottom of the feature and further away from each other at the top of that feature, then we can say that that particular slope has a convex slope. That is what we have actually learned from identifying contour patterns with the slope of the land. You were given 3 lots of activities to actually complete for your homework, and those 3 lots of activities were supposed to see you look at a topographic map and identify the steepness of the slope or the type of the slope in those areas that were given. Okay, let's check that one out now for correction, and that is the homework that you were given. Referring to the map of Sogeri, the topographic map of Sogeri that you should have, page 8, you first of all identify the area that you're supposed to describe the slope of, and the area with the grid reference 455,513. So if you look at 455,513 to 460,517 to 460,517. What type of slope is actually found in that area, given the grid reference, the 6-figure grid reference that is? What type of slope? What do you have, Gideon?
Concave slope.
Okay, he says it is a concave slope. Let's check. The area that we are looking for, the slope is in 455,513. Check 455,513 to 460,517. So we are going from 455,513 to 460,517. He says it is a concave, which means at the bottom of the feature, the contour lines will be further apart, and at the top of the feature, they will be close together, according to Gideon's answer. Do we agree with him on that answer? You check. Do you agree with him on that answer? Yes? So at the top of that slope, contour lines are close together. At the bottom of that slope, they are further away from each other. We are going from 455,513. That's your starting point. And you go to 460,517. We happy with Gideon's answer? Our friends at the back, we happy with that answer? Yes? No? Can we all double check on that starting point? 455,513, have you found that? Okay, that's where you are starting. Okay, you're going to 460,517. Are you going up or are you coming down? You're going up. So therefore, as you are going to the top of the feature, we're starting from 455,513. Are the lines closer together or are they further away from each other? They are closer? And as you are going to 460,517, are they close together or further away? Further away. So that's going to the top where the lines are further away from each other. So therefore, we would have a convex slope. Okay, it's supposed to be a convex. And that's the reason why I'm telling you to double check. The starting point, and we are going up closer together. The contours would be at the top and at the bottom of that feature. Sorry, I'll rephrase that. At the top of that feature, they are further away from each other. At the bottom, they are close together. Therefore, our answer as given by Gideon was concave, and that is not correct. It is supposed to be a convex slope. Okay, good. Let's look at the second of the questions for homework. This time it is 468, 522, that's the starting point, to 475, 522. What would be our answer? Christopher, what is your answer for the type of slope that you will find in the grid reference 468522 to 475522? Okay, Christopher, your answer?
Uniform.
Would you like to stand up, please, and give that answer again?
Uniform slope.
Okay, very good. I will also agree with him that that particular point of reference given, the answer should be a uniform slope because the contour lines are of the same distance apart. Good. Finally, the last area is within a grid square, and the grid square is 4751. 4751. What type of slope would you find in the grid square 4751? Silo, your answer for that question.
Uniform slope.
Uniform, we double check. All happy with the uniform slope? No, okay, some students are not happy with that. I will not agree with you on that also. Someone else who might have the answer. Rebecca, your answer? We're making correction to the last point of reference there, 4751.
My answer is gentle.
Okay, good. Very good. Actually, I will agree with you that the slope there in that square 4751 will be gentle slope. The reason why I am not accepting a uniform slope is that if you look carefully in that square or that grid, the contours are not the same distance apart. Some of them are a bit closer, some of them are a bit further apart. But if we're looking at either whether that area is steep or gentle, you'll find that most of the contour lines are further apart from each other, but not at the same distance. Therefore, the answer will be gentle. Okay, let's do some more activities. Another two more lot of activities to see if we really understood what we were trying to do there for identifying types of slope. Referring to the same map, very quickly now, see if you can identify what type of slope is found in the area or grid reference given 410, 510, 410, 510, to 414, 514. I'll repeat. 410, 510, to 414, 514. That's the first area that you look at for the type of slope. And the second one is a grid square. Number 2, what type of slope is found in the grid square 3953? 3953. That should take you only 2 minutes if we are already familiar and know what we're supposed to do here. Okay, very quickly check on the type of slope in those two areas given. Anyone got the answer for the first one? 410510 to 414514. Anyone got an answer? Ovio, what is your answer? Okay, that's for the first one, 410510 to 414514. Okay, Ovio is going to give us an answer for that one.
Concave slope.
A concave slope, and I will definitely agree with you. It's a concave slope. You check. Everyone, check. Concave? Yes, definitely. Where you have contour lines are close at the top and wide at the bottom of that feature. The second one, the grid square, 3953. Kathy, found an answer? No? Caleb? For the second example, 3953. Mason? Mason's got an answer?
Uniform slope.
Uniform slope, everyone check. We're going to be happy with the uniform slope, that the contours are of the same distance apart. Check properly. Are all the contours within that grid square of the same distance apart? No? Okay, Kathy, what is your answer then?
Gentle slope.
Okay, I will definitely agree with you on that also. Gentle slope, simply because the contours are not of the same distance apart. Okay, we have to be a little bit quicker with locating features of such when we are given topographic maps, because don't forget, when you sit for your grade 12 exam at the end of next year, you'll have only 1 hour to complete 30 questions that are going to be given. And if it's going to take you 5 to 10 minutes to identify the type of slope only on one question, then you might not be able to complete the rest of the other questions that are going to be asked. So we're giving you practice to be a little bit more quicker in trying to, first of all, locate those places using the grid references that you have learned. And then secondly, if you can recognize the type of patterns that you are looking at, then you should be able to work out the type of slope that you are dealing with in that area, given area that is. Okay, we are going to move away now from looking at slopes. And the last thing that I'd like us to do working with contours is looking at identifying contour patterns and working out what type of landform in reality a particular pattern should represent. Because when you look at the contour patterns in a topographic maps, they are supposed to also tell you what type of landform you are looking at in reality. And if you can know or identify the type of pattern and then work out the type of landform, then that part of the activity you have actually gained or you know already. Certain types of contour patterns should represent certain type of landform in reality. So we will start off first, before my explanation of the different contour patterns with the type of slope or type of relief that is in reality, we will start off first with an activity. And in that activity, there are 6 contour patterns that are given. And then from the 6 contour patterns, they are also giving us relief model, or in other words, features, what they would be like in reality. So your task now is to see if you can match those patterns with the relief model. And all you are going to do is you write down number 1 to 6, and then beside each of those numbers, work out or match which of those relief models would be the correct one to go with those patterns. If you'd like to make a quick sketch of the relief model and also the patterns, you can do that, but match them first of all. Yes? Okay. We're going to check the answers now. If you look at contour pattern 1. Contour pattern 1. The lines are very close together on the left-hand side of the feature. They're further away on the right. Therefore, it will be matched with the relief model number or letter B. So 1 will go with B. You check. B on this side here is steep. On the other side is gentle, as shown by the contour pattern. Okay, let's check contour pattern number 2. If you look carefully at contour pattern number 2, it's got a circular contour here, 1 in the middle, 1 on the far right hand. To match it with the relief model, it will be E. So number 2, contour pattern will go with E model. Number 3, a nice circular contour. And number 3 contour pattern will go with the model F. So 3 will go with F. Contour pattern 4, you will note that contour pattern 4 is about similar to that of contour pattern number 2. The only difference is that in number 2, there are more circular contour patterns around the middle feature compared to the 2 circular contour patterns on each side of that model or feature. And when you come to number 4, the pattern 4, you will note that there are more circular contour patterns on the far right than the middle and the left. Therefore, the far right would be higher than the left. So 4 will go with A, model A. Contour pattern 5 will go with D. Again, on the right side, contours are close together. On the left, they go further away from each other, so that will be represented by the model D. And finally, contour pattern 6, very nice circular contours close together, so you have a feature like that, a relief model feature of that of C to match with the pattern 6. So we'll go through the answers again. 1B, 2E, 3F, 4A, 5D, and 6C. What you have actually basically done here is that you have matched the patterns with relief or landform. And that's what we are going to actually do for our lesson today. We're going to look at some of the common landform features, that is, and then what we will try to do is see if we can identify what type of patterns are supposed to show those major landforms. And if we're going to start off, instead of starting off from the chart, we'll start off from the information on the monitor and looking at the different relief or landform, that is, identifying there are different contour patterns that should represent those landforms in reality. So basically what we are looking at here are the landforms in terms of their side view, what they would look like in reality, or the side view of a particular landform if you were given a pattern of such. And the first of those landforms that we are going to look at is that of hills and mountains. So you could imagine hills and mountains. Hills and mountains are represented on maps, topographic maps that is, by enclosed contours which get higher towards the center. And if you look at the pattern, you start off with low values or smaller values, but as you get to the center of the feature, you will find that the values increase. And when that happens, you start from a lower value and the values go in a circular contour pattern right to the top and it increases, then you know that that feature could be of a hill or a mountain. And hills or mountains are shown with a circular contour pattern, value lower at the bottom, and it gets bigger towards the center of that particular pattern. So that's the first of the contour patterns we're going to look at. The second one. You also have contour patterns like what we've done already, whereby on one side of the pattern, the lines are so close together. On the other side, the patterns are further apart. Or sorry, not the patterns, but the contour lines are further apart. And when you have a contour pattern of such, then the feature is one that has a steep slope where the contours are close together and a gentle slope where the contours are further apart or away from each other. And this feature here is called an escapement. Steep slopes are indicated by close spacing of contour lines, like here. And this is because the height increases rapidly over a short distance. Therefore, the contour lines very close together. The hill on the left is much steeper. That means on this side is much steeper than the one on the right. And this is clearly indicated on the contour map by the spacing of the contours. So if you look at the contour pattern, where you see the lines closer together on one side, a shape like this, circular shape that is, but contours closer on one side, further away from the other, then the feature is that of an escapement. And in an escapement, we can tell the scap and the dip. Okay, I'll explain that a little bit more when we look at the information from the chart. Okay, the next contour pattern is that of the landform called ridge. A ridge is usually found between two valleys, and it can be recognized on a contour map by the V-shaped contour pattern. So when you look at the contour pattern, notice the V shape that is actually shown by the pattern. But note also that the V-shape patterns are pointing downhill. And it's important for us to be able to recognize this, because if we don't get this right, when we come to looking at the next contour pattern of a valley, we will make a mistake. So for a ridge, we look for the V shape, but checking to see that the V shapes are pointing downhill. How do we know that the V is pointing downhill? We simply look at the value of the contour line. So here it's 100, 200, 300, 400, 500, up to 700. But the contours are not pointing up to where 700 is, the V shape that is. They are pointing down to where the smaller value is. So this tells you that this is a contour pattern of a ridge, because then the V's are pointing to the, or pointing downhill. Okay, so a contour pattern of a ridge will look like the one as shown here. Look at the next one. This time, the landform of a valley. And valleys are an important feature of the landscape. They are usually associated with a stream or river, but they can also be recognized by their contour patterns by a V-shaped pattern. The difference between a ridge and a valley is that the V shape this time for a valley usually would point, or will always point, uphill. And how do I know that the V is pointing uphill? I simply look at the values of the contours. I start from the bottom here at maybe 50, 100, 150, 200, 250, 300, 350, 400, and I'm going uphill. But look at the way in which the V's are pointing. The V's are pointing uphill. And that then will show us a contour of a valley. Let's go back to that of a ridge. The reason why I wanted you to look at this carefully and note is because they are very similar. The only difference would be the way in which the V's are pointing. Do we all know where the V's are from this diagram? Okay, the V is the way in which the contours are actually drawn. The V's are pointing downhill for a ridge. For a valley, the V's are pointing uphill. That's why sometimes they call valleys also U-shaped valleys or V-shaped valleys, because of the way in which they have been sculptured or constructed in the sense of natural processes occurring. Rivers, that is, forming these features here called valleys. Finally, sometimes when we look at mountains or hills, we can say automatically that the contour patterns are nice, round, circular patterns. But how do we know at the top of the hill there is no maybe depression there, like in the case of a volcano? We can only know that when another important feature is actually represented or presented on the contour patterns. And that is what we call, that is a series of enclosed short bars which are actually drawn at the top of the feature where the contours start to go down in the case of a depression. So if you look very carefully at this particular pattern here, they tend to have what we call bars which are pointing towards the center, and the bars are telling us that as you reach the top of the feature, there is a depression at the top of the feature. So for a volcano, the bars will be drawn to show us that that volcano has a crater at the top, or if it has all blown off, then a caldera might be we are looking at, or any other type of depression whereby the feature does not go straight to the top, but rather it comes to the highest point, and then as you reach the highest point, there is a drop. Then they are represented by the bars, which are drawn on contour lines. Okay, so whenever you see the bars there, you know it's a hill, but at the top of the hill, there is a depression. Good example would be those of volcanoes. Any questions? Yes, Val?
When they're showing the height in meters, do they give the depression, like if it's below 100 meters or something below sea level? Will they give it?
Good question. We already know that if you are talking about contours, the contour interval of a map will always be constant. So if the contour interval of this map, say for example, is 50, we start off with 350, 400, 450, 500, 550, etc. Then you note that as you are going up, what will happen is that every line that you go up by, it will be 50 meters added on. As soon as you come to looking at the bars that are drawn, then you know that that is the start of the depression. So you are going to go down by 50 meters. So it is constant, the contour interval, or as you're going up or coming down. For every line, you know already that you will go up by 10 meters or 5 meters, depending. So as soon as you come to the depression, then you know that you will be going down by 5 or 10 or 15, depending on the contour interval of the map. Because still every line that is shown must have a value. And the value of that line is dependent upon the contour interval of that map. Only that the bar that is showing you is that you are no longer going to add, because you are no longer going uphill. You are now going down. So you have to minus by the interval. Does that answer your question, Val? Okay. So the contour interval remains. It's just that we get to see that is a depression. So that means we have to go down. We are not going to add to go up. Any other questions? Okay, if there are no other questions, we will look at the rest of the other contour patterns in our next lesson. We'll start off first with the common ones. And for your homework, maybe what I will ask you to do is to make note of these features from the chart here. And then when you come back for our lesson tomorrow, then I'll go through looking at the information that's presented here on our chart. I think, class, that will also bring us to the end of our lesson. For your homework is try to recognize the major patterns and the landform features that we've looked at so far, and also make note of the information which is on the chart. This chart will be placed in your classroom so that you can spend some time copying down the notes from it. If you can stand up now. Okay, good afternoon, and thank you, students. To the pilot teachers, our keyword for today is Contours 2, that's lesson 11.